Hey everyone, and welcome to WittCode, where in this video I'm going to be going over everything there is to know about the module object in Node.js. But before I start this video, I want to go over what a module actually is, different module system types that exist, and some brief history on how modules came to be. So a module is code that we group together for sharing and reuse. In other words, a module is essentially code in one file, or even a folder, as you'll see later, that can be used in another file. The code in a module is usually related. For example, we could have a module of mathematical functions that we export, or we could have a module that interacts with a database. So the main function of modules is to allow us to break down the complexity of our applications into smaller chunks. In other words, turn one big program into separate smaller programs that work together. There are many obvious benefits to this, including making it easier to track down bug fixes, add new features to your application, and so on. And now for some history. So originally, JavaScript started in the browser, and there was no module system at all, because JavaScript was a small language made to perform small tasks. So it didn't need a module system because the programs made with JavaScript weren't expected to be big enough. But as would be expected, JavaScript applications began to grow in both size and complexity, so having the ability to break down big applications into smaller pieces was desired by developers. This is when a variety of competing module formats emerged, including the asynchronous module definition, or AMD format, the ES module format, system.register format, universal module definition format, or UMD, and common JS format, or CJS. Then, when Node was being invented, modules were of course one of the most desired things to be implemented. The format chosen for use in Node was common JS, which uses require and module.exports to define modules. So, module.exports is the instruction that tells Node what parts of the code, such as strings, functions, objects, variables, etc., should be exported from a given file so other files can use it. So real quick, let me just log out the module object here, and let me pull up a terminal so I can run this, node index.js. And so this is what we're really going to be going over in this video. Each one of these keys, what they mean, how we can alter them, and then of course also just interacting with require and module.exports in folders and files. But to start this off, we're going to be working with this key here, the exports key. So before I do more of this, what I first want to do to start this video is I'm going to create a couple users in here that we can make modules and stuff to interact with them. I'll show you this in a second. Let's make one user WittCode, and then let's create another user. Also, let me close this. Don't think we need this right now. And set this equal to and now let's make a function that loops through the users and prints each user's name and age. So I'm just going to do this function print names. I'm going to pass in args, which basically means we can pass in as many arguments as we want. And then for each user, we are going to log their name. And let's actually do it with this syntax here. We're going to log their name and also their age. And as a side note, the three dots here, I mentioned this briefly, is spread syntax that allows an iterable, which is basically an array, string, or just something you can iterate over that you can use with functions where 0 or more arguments are expected. In other words, you don't know how many arguments will be passed to this print name function. And then of course, let's just call this function real quick. So I'm going to do print name, and what we're going to pass in is user1 and user2. And let's see what happens when we run this program. So you can see, hi, my name is WittCode, I'm 26, and hi, my name is Mike, and I am 31. But now, let's say that we wanted to have this file to solely hold our user objects, and we want every function that works with users to be in a file called userfunctions.js. So let's create a file called userfunctions.js, and this will make more sense when you see this. And then let's just paste this function in here. So let's take this, so we only have our users in there, and then let's get rid of this. and then go back and save this one as well. But now, so go back in here, to make this function available to other files, we need to use module.exports. So if I do module.exports equals like this, and close this again, then this can be accessed from our users file or our index.js file by using the require function and passing in the path to the file. So say we wanted to use this function here, all we would need to do is const print names, set that equal to require, and then we specify the location, which .dash means in our current directory. And let's just save this. And now to access this, all we're going to have to do is just call print names within here, and then pass in our user1 and user2 again. So then let me run this. And you can see we get the exact same print as we did when we had the function declared in here. And so technically speaking, this require function loads the contents of the file into memory so it can be used. So here's a good time to show you the contents of module.exports. So let me log. If we log module here, you can see we get all this again. And let's focus on this exports key. Or sorry, not in here. If we go into here and we log out module, first let's log module and see what we get. Sorry, I'd have to run this program. You can see we get this printed out, and we have something in our exports key. And of course, if we just want to focus on this, we just have to do module.exports. And now, let's run this again. You can see we get a function print name. And so what this is essentially telling you is that what was exported was solely a function. This is why we can set the variable print names in our user.js file equal to require user functions, because it is exporting this function directly. So this is only exporting this function. So when we do require or const print names here equals this, we are essentially having const print names here. However, what if we exported our function from userfunctions.js as an object? So instead of just exporting this function directly, what if we had an object like this? Well, let's find out. Let's use the key here, print names, and then let's provide this function as the value. And press save. And now let's go back to our index file and let's run this. So let's run index.js, and you can see what we get is an error saying print names is not a function. And this is because now we are returning an object from the userfunctions.js file, not solely a function. So if we go in here and we run this again, now you can see we're exporting an object that has the key print names. So we can't access this function or this function here directly. But now, because this is returning an object, or this require function here is now returning an object, or this object here, let me highlight it, this one here, what we can do is we can use object deconstruction to get the print names method. So if we run this, and now we run index.js, you can see it works fine. So we get, hi, my name is WittCode, I'm 26. Hi, my name is Mike, I'm 31. Or instead of doing object deconstruction, we could return the whole module.exports object and access the key of that object. So we could do make a variable called user functions, and then if we wanted to get our print names function, we would just do equals user functions dot print names, because this returns this object here, and then within that object we have the key print names, so we just access it by user functions dot print names. On another note, setting module.exports in here equal to an object is also very useful, because now we can export multiple functions that are referenced by keys. So we have a key called print names, which references our print names function. So let's create another function in our users function module that sums up all the ages of our users and returns the total number. So down here, I'm actually going to create function sum ages, and we're going to pass in spread syntax of args again. And I'm going to do total age equals args dot, I'm going to use the array reduce method, and this is the aggregation, total age. This is our current user that will be passed in. And then we are going to start out with a value of 0. if you know how or don't know how reduce works, it basically takes, this is an accumulator, so each time it loops through, this will be increased essentially, and this is the starting value of it here. So what we just want to do is we return total age plus the current user and their age. And then after that, let's just log in the sum of the users' ages is $total age. So now let's make another key in here called sum ages, and we will pass it sum ages. And also, just real quick, because these are the same name, all we would have to do is we could just say sum ages. We don't have to do sum ages, but I'll just keep it this way because I think it makes it easier to read. And now let's also look at our module.exports variable again. So in here, let's do this. Let's run node user functions.js. And now you can see we have in our exported object, or in module.exports, we have an object with the keys print names and sum ages. And so now we can access this function in here with our require method the same way we did with print names function using object deconstruction. So let's say we have print names, and now we also have sum ages. Because remember, this is returning this object here with these keys that represent these functions. So when we retrieve them from the file using require, we can then just access these functions. So now we can do sum ages, user1 and user2. And now let's see what happens when we run this. We get the sum of the user's ages is 57, which of course is 31 plus 26. And also, we have only been working with functions in here, so we've only been exporting functions, but we can of course export whatever it is we want. So let's say we wanted to export like an integer, for example. We could make something like max num users is 21. We could do, say we want to pass an array, we could do, pizza, spaghetti, or burgers, or say we wanted to export even another, like a nested object. We could do user gaming consoles, and say we could do like Xbox true, PlayStation false, Switch true, or something like this. And now let me show you what this object would look like here if we did user functions.js. You can see we have all of this stuff in here now, and we could just access this exact same way. So we could do user fave food, user gaming consoles, and what was the other one, like max num users, and then we could just log those out here. So log user fave food, user gaming consoles, and what was it, max num users. And let's run this. You can see we get everything printed out. So just know you're not restricted to only exporting functions, but also numbers, arrays, and other objects. And so if we also go in here, we've just been logging module.exports. Let me show you the whole module object again. Or here, you can see we have the exports key now is populated with all the stuff that we put in here. And now I want to start looking deeper into not only module.exports, but module as well. So the keyword exports is just a property of the module object, as you've seen. There are many other properties to module, which you can see here, not just exports. In fact, the keyword module is itself a module that is available on the global scope. And this is why we don't need to do require module. So we don't have to do something like require module because it is available on the global scope in Node. So let me get rid of this. But a good way to think of the keyword module is that it is an organizer of all the required modules. You'll see more of this, or this might not make sense right now, but you'll see more of this in a bit. So for now, let's just log it. So say I'm just going to do here. Let me just log. Well, I already did, so we're going to have here, and let's look at the ID key. So the first field we see, or the first key we see here, is ID. And every module has an ID property to identify it. And the ID is essentially the path to the file. So the reason it is just a dot here is because it is in the same directory. So we're logging this module, and it is in, of course, this directory. But of course, we can set this to be whatever we want. So say we did module.id equals user functions. Now if we log this, you can see the ID is user functions. And now the next key we can talk about is the paths key. So this paths right here. And as I stated earlier, when we require a module, we load the contents of the file into memory. However, to load the contents of the file into memory, we need to find the absolute location of the file. And now, Node has many ways to find the location of a file so that it can be loaded into memory. It can be the relative path, the absolute path, a pre-configured path, or just anything. But if we require a module or file without specifying the path to it, Node will look for the specified module in the paths specified by modules.paths in the provided order, starting from top to bottom. So it'll first look for our module here. If it can't find it there, it'll look for it in here, and so on. So let me give you an example to better show this. So in here, let me get rid of all this stuff. Let's say I just say const user functions equals require user functions, like this. Let's run node index.js. You can see that we get a cannot find module user functions, or we get a cannot find module error. But now let's do some cool trick right here. Let's create a folder and call it just node modules. And let's place this user function within here. And let's add in here just a log saying user functions module has been found. And now let's run index.js. You can see that we don't get a module not found error. So after we have placed the module in a node_modules folder, we no longer get a module not found error. And so if you remember, if we go into paths, say we go in here, and we just change this instead of user functions found, and we just log module, and we run user functions, if we run index.js, you can see it's because it is looking in node modules or modules video - node modules first, which of course now exists because we made it. So you also may be wondering what the node modules folder is. Well, the node modules folder is used to save all your downloaded packages from npm on your computer for the node project you have. So if we ran npm install bcrypt, for example, so say I did npm install bcrypt, then what it would do after we've done this is it would create a node_modules folder. As you can see here what it's done, but we already created it, of course. But it would create this folder to hold the external bcrypt module that our project depends on. But we can, of course, as you've seen, just create the folder ourselves and put our own module in there. So we still have user functions just sitting in here. But so just to reiterate, we no longer got the module not found error because the module.paths key will search for modules in the node modules folder when the module provided to the require function here doesn't have a specified path. Because remember, we were specifying a path by doing .dash and then user functions. But because we aren't providing a path, it's going to search in module or inside the module.paths. So node user functions, we go into node modules, and let's do node user functions.js. So it will look here in node modules, and then if it can't find it in there, it'll go up to just node modules in the node directory, and then into documents, then into users, all the way up to the C drive. So essentially the module.paths key is a list of node module directories under every directory in your computer from your current directory to the root directory. In other words, the order of resolution starts from the most local towards the globally available modules. And now, the next thing I wanted to talk about was what if you wanted to require a folder, because modules don't have to be files, they can also be folders. So as a note on requiring folders, when you require a folder using this require method, the require method will automatically search for an index.js file, and if it doesn't find one, then it will throw a module not found error. So let me show you this I'm going to create a folder. Let me close this. I'm going to create a folder called my folder module, and then I'm going to make another, I'll call it, not inside here. Let's make another file out here. Or no, let's create one inside this called my folder file.js. And then in our index.js, let me get rid of this again. Let's require this folder. So if I do const my folder module equals require, and then I do dot dash my folder module, let's see what happens if we run our index.js file. You can see that we get an error. Or sorry, that's because I put a semicolon in here. You can see that if we run this, we get a module, cannot find module, dot dash my folder. But if we add an index file in here, so index.js, and then we run this again, you can see we don't get that error anymore. Of course, though, we can require a file inside the folder that doesn't have to be called index.js. So, in other words, if we went in here, we could do my folder dash my folder like this, and then if we run it, we don't get the not found error. However, as with most things in JavaScript land, this is completely customizable. In other words, we don't have to have it so that when you require a folder, it must have an index.js file. If we don't want the index.js file to be the file that must be present when requiring a folder, we can change this by implementing a package.json file and altering a few things in there. So what I could do is I could just, in here, create a package.json file. Or sorry, not inside here. Inside our main structure, let me create a package.json. And so a package.json file is a file at the root of your Node project that holds metadata relevant to your project and is also used to manage your project's dependencies, versions, and much more. So we can actually quickly create a package.json file by using the command npm init. So npm init is a command to initialize your project. So if we wanted our folder, my folder, to be its own project, this one here, the my folder module, let's cd into that. We could run npm init inside it, and then we could specify the folder that is required, or the file that is required instead of index.js. So if I run npm init here, and I'm just going to leave some defaults, the only required info here is actually the version and the package name, but adding more info is just best practice. But for this educational purpose, I'm just going to say yes to everything. But let's go inside here, and now you can see we have a package.json file that was created by npm init. So let's go into it, and if we want to have a different file other than index.js, when we require the folder, we just have to change the file name provided to main. So let's just change this to my folder file.js. And now if we require this again, we just get rid of this. Let's also delete this index.js file. If we require this and run, you can see we don't get a module not found error. But if we went in here and we changed this again, let's just do soccer.js, and we ran this, you can see we get module not found. Also, something you may have noticed, let me show you this actually. If we go in here, let's log you have found my folder file. Let's run node index.js. Or sorry, let me change in this back to my folder file. If we run this, you may notice that whenever we require a file or a folder, the contents in that module was executed. And this is shown by how console.log was run. So we don't have console.log, you have found my folder file in here in Node or in our index.js file, but we do inside our my folder file. And if we don't want this to happen, This means we only want to resolve the module and not execute it. And this can be done actually with require.resolve. So now if I run this, you can see we don't actually get "you have found my folder file" printed out to the console. But if we get rid of resolve and run this, you can see we do. So the require.resolve method right here does not load the file. Instead, it returns the full path of the file when it is found. So if I logged, for example, my folder module like this, and we ran this program, you can see we get the absolute path to my folder file.js. So it returns the full path of the file when it is found. But it will still throw an error if the file does not exist, similar to how require does. You might be wondering some uses for this, but some uses for this include checking whether an optional package is installed or not, and also just checking the path of the module. And now the next part of the module object I want to go over is parent-child relationships. So when you require a module in a file, that file's module object's children key gets populated with the module that you are requiring. So for example, let me go in here, get rid of this, and let me just log module in here. So let me log this module. So you can see up here we have our children key of our module object, and within it you can see we have a module which is the myfolderfile.js, which is what we are requiring here. So basically this children key is an array of the required modules. And the ID of the required module, you can see, is the absolute path of the file unless a module.id is given. So you can see the ID is the path to myfolderfile.js. But if we went in here, say we did module.id equals soccer, like this, and we ran this again, now if we go up here, you can see the ID is soccer. But so that's just what the children key is. So run it again, and you can see we get the absolute path. And it should be noted that when you use require.resolve on a module, so like this module would not be added to this array of children modules. So you can see the children array is empty. So this module, let me get rid of this again and run this. So this children key here is an array of all the modules that the given module requires. So here we require this module, so it's going to be in our children. And a key that is related to the children key is the parent key. And I'm not going to go over this key in depth as it is deprecated since Node 14.6.0. But so let me show you how if I log module.parent, you can see it's struck through because it's been deprecated. And instead, what you should use, or should be using, is require.main, which we're about to go over, or module.children. Essentially though, the parent is the module that caused the script to be interpreted and cached. But that's all you really need to know about that because it's been deprecated. But now I'll briefly talk about require.main. So when a file is run directly from Node.js, require.main is set to its module. In other words, you can determine whether a file has been run directly by using require.main. So if I did this, for example, .main equals module log, this program was run directly. If I run this, you can see we get printed, this program was run directly. And now if I do here and I say, let me just print it actually, I get this and I put it inside here. And then remember, we're requiring this, so you'd think this would be logged. But if we run this, you can see that it doesn't get logged. But now, say we go to my folder and we do node my folder file, you can see this program was run directly. But now, the next key that I want to talk about in this module object, so let me run this again. Next key I want to talk about is the loaded key. So this key right here, loaded. And you may have noticed in this video that it has always had the value false. And modules use the loaded attribute to track which modules have been loaded, which equates to true, and which are still being loaded, which equates to false. So we can see this value equate to true if we use the setImmediate function that is provided by Node. So say I do here set immediate, and then what we do is this. Let's run this now. And you can see we have loaded set to true. And so this function here, set immediate, is used if you want to execute some piece of code asynchronously, but as soon as possible. In other words, anything passed to the set immediate function is a callback that is executed in the next iteration of the event loop. And if you haven't heard of the event loop, that is essentially JavaScript's way to perform non-blocking operations, or operations that don't stop other operations from happening. So the reason the module has been loaded in this case is because we are logging the module on the next cycle of the event loop by using the setImmediate function. It was false when we logged the module right away because while the module is still being loaded, we log it, but when the event loop goes around once more, the module has then been loaded. And this leads to our next topic of discussion. The whole process of requiring and loading a module is synchronous, and this means that the exports object becomes complete when Node finishes loading the module. And this is why the module was fully loaded during the second cycle of the event loop. However, because the requiring and loading of a module is synchronous, we can't change the exports object asynchronously. So let me show you this real quick. So what I'm actually going to do to demonstrate this is I'm going to create a text file called mypassword. Or I'll just call it password.text. And in here, I'm just going to say, this is my password, and then do it as one word, my password. And now let's create another file in here. Let's call this just synchronous.js, and we're going to require the file system module, so fs like this. And remember this, the reason it's finding this is because this is a global module. But now to show you the synchronous part about loading modules, let's see what happens if I do this. And then we do fs.read file, which is an asynchronous method, password.text, and then for the callback, we're going to set the module.exports password equal to data. So this method here is asynchronous. If we wanted to use the synchronous one, it's file, read file, sync. But so now let's see what happens if we require this module. So within here, what I'm going to do is I'm going to say const my module equals require, then dot dash, what do we call it? Synchronous.js. Of course, I did that again. And now let's just log out, not this, but let's log my module. So if we run this, or sorry, of course we forgot this parenthesis again. Let's run this. You can see we get soccer printed out, but we don't get, where was it? Data, or this printed out, this password, because it is an asynchronous method. You can see because this is asynchronous, we only get soccer logged, because this hasn't actually been added to our module.exports. And now what I want to talk about is circular module dependency. In other words, you have two modules that both require each other. So to demonstrate this, I'm going to create a file called cycle module1.js. I'm going to make another one called cycle module2.js. And within cycle module 1, let me get rid of these. Within cycle module 1, let's do module.exports .part1, and close this out here, equals before requiring module 2. You'll see this come together when we run this. And then cycle module 2, set that equal to require dot dash cycle module 2. And then let's do module.exports part 2 equals after requiring module 2. Save this. And now let's go into cycle module 2 and let's do const cycle module 1 equals require dot dash cycle module 1, and then let's log cycle module 1. So now let's run cycle module 1, and you can see how the only thing that is printed is before requiring module 2. So only part 1 in here, part 1 has been printed. And now before I go over this, also let me just show you what happens if we log the module. So say I do log module like this, and let's run cycle module 1. You can see the children here has the key parent as circular. And then if we also do this in cycle module 2, so we log module here, then we run cycle module 2.js, you can see once again the parent is circular. So the reason for this logging situation is because we required cycle module 2 before cycle module 1 was fully loaded. So you can see here we required cycle module 2 before cycle module 1 was fully loaded. And since cycle module 1 wasn't fully loaded, we only get an exports object that has the properties exported before the circular dependency. In other words, we only got the part 1 property because the part 2 property was exported after cycle module 2, and here required cycle module 1. And it is cycle module 2 here that logged cycle module 1. So this can get pretty confusing, and as part of the reason, honestly the main reason I showed you this is just to try and avoid circular dependencies because they are really confusing. However, Node does try to keep circular dependencies simple. As you just saw, when a module is loaded, the exports object is built, but you can still require the module before it's done loading. This will cause you to get a partial exports object, in other words, an exports object that contains what was defined before requiring the module. And now I want to change gears and talk about something cool with Node, and that is that you can also use the require function on JSON files and C or C++ add-on files. In other words, you can have modules that aren't just JavaScript files. But before I go any further, let me give a brief rundown of what an add-on is. An add-on is formally known as a compiled library of functions used by a Node application, and what it does is store binary data written in C++. But essentially, for now, just know that we can require JSON files and C++ add-on files with the require function. We don't need to specify the file extension, and we can even see what extensions the require function can take by logging out require.extensions. So let me do log require.extensions, and let's just run index.js, and you can see what we get is it looks for JavaScript, it looks for JSON files, and it looks for .node. So what this is essentially saying is if a file extension isn't provided, Node will first think the file is a JavaScript file with a .js extension. If it can't find a .js extension, it will try a .json extension, and if the file isn't a .json file, then it will try to find a .node file, and a node file contains an add-on. But anyway, let me show you this first by requiring a JSON file. So let's just do JSON.js, or not JS, JSON, let's rename this myJSON.json, and then in here, let's just JSON syntax is always double quotes around the key and around the value. So soccer, let's do fun, let's do pizza, delicious, like this. And now if we go into our index file, let's get rid of this. Let's get rid of all this, actually, we don't need this anymore. And let's do const soccer pizza equals require dot dash my JSON. And then if we save that, now let's log soccer, and let's also log pizza. And you can see we get fun and delicious. So we can require .json files as well, which is pretty cool. And now I'm not going to go into the C++ add-on file in this video, as I want to make a separate video to cover this, as it is a pretty large topic. But for now, just know that you can also require C++ add-on files. But now the next topic that I want to go over is module wrapping. So Node wraps all the modules with a function as they are being loaded, as not to pollute the global namespace. For example, as you've seen earlier, when we define a variable in one module, the other modules in the program will not have access to that variable unless we export it. And this is because of the function that wraps the module. And this function that wraps the module can be seen by logging the module. So let's do my module equals require, and then just module like this. Close this down again, and then let's log my module dot wrapper. And if we run this, you can see the function that is exported. So it's a function with the arguments exports, require, module, _ file name, and _ dir name. So when you run a file with Node, the code you wrote doesn't get executed directly. Instead, the wrapper function has the code you wrote in its body, and it is the wrapper function that is executed. So from the console, you can see that this wrapper function has 5 arguments. Exports, which represents, or which is a reference to the module.exports, require and module, which are specific to the wrapper function that will be executed, and _ file name and _ dir name, which will have the wrapped module's absolute file name and directory path. Also, we can access these wrapper function arguments by using the arguments keyword, which returns an array of arguments passed to a function. So let's log the keyword arguments. Let's see what we get. So you can see that the first element in the array is the, is the exports, or 0 here. Next is require. So you can see this is the key 1, which is require. And then 2 is the module. So you can see that's the second argument is the module. And then 3 is the file name, which you can see here. And then 4 is the directory name, which you can see here. But now, you may have put together that the return value of the wrapper function is module.exports. So this is why when you require a module, you get that module's exports, because those are what are returned from the wrapper function. So that's what I wanted to talk about module wrapping, but now let's talk about module caching. So you may know that caching is a technique to improve an application's performance. Well, when you require a file with Node, it is cached. And to demonstrate this, let's see what happens if we require a module that logs something twice. So let me make another file in here. I'm going to call it catch.js, and let's log was I catched, like this. And then in index.js, let's just do const. We'll do const, let's say my catch equals require dot dash catched. And then let's see what happens if we run this. So it should log was I catched. Now let's see what happens if we require it again. Let's do my catch to require dot dash catched. If we run this, you can see it wasn't logged when we required it a second time. And this is because Node catches the modules on the first call, and so it does not load the file on the second call. You can physically see the catching by actually printing require.cache. So if we do require.cache like this, and we run this, you can see we get an object containing the cached modules. And the one that is, where is it? You can see we get node.index.js, but we also get right here our module catch.js. But yeah, so you can see how we have those two here. We have the one that the module that we were working with, and also the cache module that we required. But so this is my video on the learning more about the require keyword and module. I might do a more of an in-depth explanation at some point, or something going on with this. If you have any questions, feel free to let me know and I'll try and get back to you. But besides that, thank you for watching.